talk about a note there. If a function is concave upward, then the second derivative is always positive at that point and around that point. Okay, if a function is concave upward, then the second derivative is always positive around that point. In that case, there is a chance of local minima. When it is concave upward, there is a chance of local minima, right? Because the graph will look like this. There is a chance of local minima, but it is not guaranteed that local minima always exist. I will show you an example later. Also, if a function is concave downward, there is always the second derivative is always negative, right? And there is a chance of local maxima, but it does not guarantee that it exists. Okay. Now, if there is a point of inflection at a point, then the second derivative must be 0 or undefined. But if the second derivative is 0 or undefined, it does not guarantee the backward. Okay, it is just true forward, but not the backward. Okay, let us see this example. This function is, let's say, this function is concave up. You see that? It is concave up from 3 to infinity. So the second derivative must be, this is concave up, right? And this is concave down. So the second derivative must be on the concave up, second derivative must be positive on 3 to infinity. And the concave down on negative infinity to 3, right? And x equals to 3 is the point of inflection. Why? Because it is the boundary between the concave up and concave down. Because it is the boundary. So the definition of the point of inflection is the boundary between concave up and concave down, or concave down and concave up. Okay, in one side it should be concave up or down, and the other side it is just the opposite of the whatever there in the one side. Okay, to be a point of inflection. So here there is a chance for the concave for second derivative positive. There is a chance of local minima because there is a concave up, right? Look at this. This is concave up. There is a chance of local minima, but in this case it does not exist because that 3 is the to have a local minima, we need to have like decreasing and then increasing, right? For the local minima, and for local maxima we need to have increasing and then decreasing. But here it is just concave up. It has increasing portion but not the decreasing portion. So it is the increasing portion on the right side, but there is no decreasing portion, right? We need to have this type of graph to have a local minima. But it is just a concave upward and downward. There is a point of inflection, but there is no local max and local mean in this graph. Okay, there is no local max and local mean in this graph. So in this graph, okay, there is the first derivative, the second derivative will be positive. I'm sorry, second derivative will be positive in this graph. So second derivative will be negative in this graph. So here is local max and local mean. This is local mean, this is local max. But in this case, the second derivative is positive, second derivative is positive here, second derivative is negative here, but there is no local max and local mean. So what I'm trying to say here is, if a function is concave up, the second derivative is positive in that region, around that point or in that region, and there is a chance of local minima, but it does not guarantee. There is a chance only. If there is a concave down, then the second derivative is negative, there is a chance of local maxima. If there is a point of inflection, then the second derivative is always 0 or undefined. But the other way does not work here, okay? The second derivative 0 does not imply the point of inflection. Okay, so let us look at this. What is the relationship between the concave up or down and local max, local mean? Okay, that's what we are going to talk here. If f has a local maximum at x equals to c, if f has a local maximum, this one is, right? When f has a local maximum at x equals to c, local minimum. If it has a local minimum at x equals to c, then the graph is concave upward. Because see, there is a local minimum, right? The graph is concave upward. Graph is concave upward. Whenever the graph is concave upward, then the second derivative must be positive, right? That's what it says. If f has a local max, this is the case of local max at x equals to c, then the graph is concave downward, right? Whenever graph is concave downward, then the second derivative will be negative around that point. But concave upward or concave downward does not guarantee the local max or local mean, as we see this in this graph, right? There is a concave upward, but there is no local max or mean. There is a concave downward, there is no local max or mean. That can happen. Okay, let us do one more example about the concave up and concave down that has a trig function. So determine the interval on which fx equals to 4x plus 6 over sine x. So 4x plus 6 over sine x. You need to look at only in this interval, only in that interval between negative pi and pi is concave upward. So let us look at this. F of x is equals to 4x plus 6 cosecant x, right? We know the formula of cosecant x, that's why I want to use that. So what is f prime? I don't want to use the quotient rule. If I keep that form, I only have to use quotient rule. That's why I just write in the simpler form. 6 times 1 over sine x is cosecant x. So 6 cosecant x. So 4 minus, what is the derivative of cosecant x? So 4 plus, what is the derivative of cosecant x? 6 negative cosecant x times cotangent x. That is same as 4 minus 6 cosecant x times cotangent x. This is the derivative. Now for the concave up or concave down, we need the second derivative, right? Let's find out the second derivative. So how much is that? This is 0, right? The derivative of 4 is 0. So you need to use the product rule here, right? Let's use f times g because the derivative of this will be 0. So we need to find out the derivative of that one. So it is negative 6 times f prime is negative cosecant x times cotangent x times g is cotangent x, right? And then plus f times g prime is cosecant x times the derivative of cotangent x is negative cosecant x square, cosecant square x. That's what you get, right? If you simplify, what do you get? Negative times negative is positive. 6 cosecant x times cotangent square x plus minus, basically there is a product of plus and minus, cosecant cube x. Oh, there is a plus 6, right? Because there is negative 6, you need to distribute with that. So can you factor out something or no? Yes, we can, right? Let us factor out 6 cosecant x. What is left is cotangent square x and then plus cosecant square x. So what are the values of x? Now we see what values of x makes f double prime 0 or undefined. If we set x equals to 0, that will be infinity because cosecant 0 is infinity and cotangent 0 is infinity as well. So x equals to 0 makes y double prime or f double prime undefined here. You understand? So x equals to 0 is basically the possible point of inflection. Okay, but f double prime 0 does not imply it is a point of inflection, right? So it may or may not be. But are there any other values that makes it 0? So cotangent square x plus cosecant. What we do is let's do f double prime equals to 0 implies 6 cosecant x times cotangent square x plus cosecant square x equals to 0, right? Either 6 cosecant x equals to 0 or cotangent square x plus cosecant square x equals to 0. You see that? But what is your x? You can take x value between negative pi and pi only. So for cosecant, it is not 0 between negative pi and pi. Cosecant x is not 0 between negative pi and pi. You can check from the graph. And these are the positive, both are positive values or zeros, right? And this cosecant and cotangent are not 0 between negative pi and pi. So cosecant x is never 0. So what we can say here is, this is not right. This is not right as well. So they cannot be 0. So f double prime of x is not 0 for this function. But can we say that, but f double prime is undefined at x equals to 0. At x equals to 0, this is undefined. Why? Because cosecant 0 is infinity, cotangent 0 is infinity as well. So you will get infinity for x equals to 0. There are other values where this f double prime is undefined, but between negative pi and pi, only x equals to 0 is the one that gives you undefined. Okay, so after you do that, our goal here is basically to find out the interval of concave upward and concave downward. Okay, so let me write down that is basically 0. At 0 it is concave. So at 0 the second derivative is 0. So what is the f double prime? So f double prime here is, and then we need to look between negative pi and positive pi only, right? So negative pi and then positive pi. F double prime is how much? F double prime is 6 cosecant x cosecant square x plus cotangent square x, right? So what we do is basically we plug in different values as a test point here. Okay, let us take a test point pi over 2, negative pi over 2, and let us take a test point as positive pi over 2. Okay, so if you do that, then if you use calculator, just plug in this thing in the calculator, and then from the graph you see that it will never be 0, and from the graph you will see that at x equals to 0 it will be undefined. F double prime will be undefined. That's how I know that x equals to 0 is the possible point of inflection. Second derivative equals to 0 does not imply that that point is the point of inflection, but we will have to show that 0 is the boundary between concave up and down. Then we can say that this is the point of inflection. Okay, so let's see that if I plug in x equals to negative pi half in my calculator, I will get negative sign. That means it is concave down, right? And there may be the chance of local max there, but the question is not asking the local max or local min, so we are just finding the concave up and concave down. Also we will see the point of inflection as well. And if you put pi over 2 for x here, you can use calculator again, you will get positive sign. So there is a chance of concave up. So this 0 is basically the boundary between concave down and concave up. So this is basically the point of inflection as well. So what we do is concave up. In which interval? 0 to pi. Concave down. In which interval? Negative pi to 0. And then point of inflection is x equals to 0. So we can determine that way here. Okay.